Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics, and previously we discussed the basic introductory concept related to thermal conduction. In this video we are going to discuss about another basic concept, which is steady state and temperature gradient of an object when it is thermal conduction is taking place. So we know there are three important mechanisms of heat transfer which we discussed in the previous video, that is conduction, convection and radiation. Currently we are discussing the thermal conduction part, and the basic concept, the basic mechanism of thermal conduction is transfer of heat from one part of an object which is at a higher temperature to another part which is at a lower temperature through continuous molecular collisions. Okay, so here we know the basic concept and we understand that every object, it has three types of energies: translatory, rotatory and vibrational. So whenever an object is heated, let's say we have a metal rod and it's heated at one end, as soon as it starts getting heated, the three kinetic energies, that is rotational, translational and vibrational, their combined average kinetic energy, it starts increasing, and as a result the amplitude of their vibration, that also starts to increase. As a result of these increased vibrations or oscillations, they collide or strike with the neighboring molecules. This is in the normal state. Okay, so in the normal state the molecules are in this manner. They have certain kinetic energy, but the amplitude of these vibrations or oscillations, it is small. When it is heated, their vibration starts to increase. These heated molecules, they collide with the neighboring molecules, transfer their energy to them, and as a result they also start vibrating with increased kinetic energy, and as a result slowly the metal rod, which is heated at one end, the heat progresses throughout the rod. A point is reached when the amplitude of the entire rod, the molecules throughout the entire rod, it starts increasing and the entire rod gets heated. This is the basic concept. Now here there are two parts. Okay, during this entire heating process, we can divide this entire process into two parts. One is the heating which is taking place under variable state, and then the steady state. Okay, so what is variable state and what is steady state? So here, as we know, in the process of thermal conduction, each cross section of the rod, it receives heat from the adjacent section. Let us say we divide this entire rod, okay, this entire rod into three parts. Okay, we take certain portion and we divide it into three parts. So here, as the heat is transferred from one end to the other, each cross section, it takes heat from the adjacent cross section. So here, as heat flows from one end to the other, some portion of the heat, it is absorbed by that cross section, which leads to an increase in temperature. Some portion is lost into the atmosphere through convection and radiation, and the rest is transferred to the next section. The entire heat is not transferred. Some portion is used up in increasing its own temperature. Some portion is lost, heat loss through convection and radiation, which we'll discuss in future in separate videos, and the remaining portion is transferred to the adjacent cross section, which leads to increase in the kinetic energy of the neighboring molecules. Okay, that portion. So here in this state, the temperature of each and every cross section here, it increases with time. Okay, so the temperature of this section, let's say let's call this 1. The temperature of this section, let's call it temperature T2, and the temperature of this cross section, let's call it T3. It starts increasing as time progresses. Okay, and the heat transfer is taking place gradually, slowly, from one end to the other, like this. Now after some period of time, okay, and let's say in order to mitigate the the problem of heat loss, we cover this rod with an insulating material so that there is no heat loss through convection and radiation. And after some period of time, a state is reached when the temperature of each and every cross section of the rod, it becomes constant. Okay, the temperature of each and every cross section of the rod, it becomes constant. So this is called as the steady state. Okay, this is called as steady state. Here each and every portion of the rod, every cross section of the rod, it behaves as an isothermal surface. Isothermal surface means the temperature of that cross section or that portion of the rod, it is constant, that portion, but the temperature of each and every point on the rod, it is different. Let's say here the starting point, okay, this starting point, this cross section, let's say it is at a temperature T0. So the temperature of each and every point on this cross section, it will be T0. Similarly, we take this cross section, okay, so here the temperature of each and every point on it, it is at temperature T1. Similarly, this surface, this cross sectional surface here, the temperature of each and every point located on this surface, it is at temperature T2, and likewise here T3. Here the temperature is continuously, it is changing, but in the steady state it has become constant. The temperature of each and every point is different, but it remains constant with time. In steady state, there is no further increase of temperature. Okay, so this is called as the steady state. Here T0 is greater than T1, is greater than T2, is greater than T3. Okay, understand the difference between variable state and steady state. Okay, so let us say we take temperature readings of this metallic rod at 3 points. Let's say this is one point, this is another point, and this is another point. And we start taking the readings. Let's say we started heating the rod at t equals to 0 second. We took one reading at 30 seconds and one reading at 60 seconds or 1 minute. So we are considering first this. At the first reading which we took, the temperature of this initial cross section, the first cross section, that is equal to how much? Let's say it is 50 degrees Celsius. Okay, the temperature of this cross section, the second cross section, let's say that is 30 degrees Celsius, and the temperature of this section T3, that is equal to 10 degrees Celsius, because the end which is closer to the source of heat, that will be at a higher temperature, and as in that way heat can pass from one end to the other. T1 will be greater than T2, will be greater than T3, like that. And at 60 seconds the heat increased to T1 dash, that is equal to, let's say, 80 degrees Celsius, T2 dash to, let's say, 60 degrees Celsius, and T3 dash to 40 degrees Celsius. Here also T1 dash is greater than T2 dash is greater than T3 dash, but the heat of each section, it has increased, it is increasing with time. This is the variable state. Similarly, if we take another reading at 90 seconds, this temperature T1 double dash, it will be, let's say, 110 degrees Celsius. This will be 90 degrees Celsius, and this will be, let's say, 70 degrees Celsius. Temperature is keeping on increasing with time. And let's say after a certain period of time, let's say t equals to 5 minutes, we arrive at a steady state. Okay, we arrive at a steady state where the final temperature is equal to T1 star. Let's say the steady state we represent to star. This is 200 degrees Celsius. This is, let's say, 150 degrees Celsius, and this is, let's say, T3 star, that is equal to let's say 100 degrees Celsius. This is not, I'm just giving you an example. Okay, so let's say after this steady state t equals to 5 minutes, there is no further increase in temperature. It is locked at this. This is the temperature, and it is not increasing beyond this. The temperature of this point is 200 degrees Celsius. It is remaining constant afterwards. The temperature of this section is 150 degrees Celsius. It is remaining constant afterward from this point. And the temperature of this section, that is 100 degrees Celsius, it is also remaining constant afterwards. So here if you see, the temperature of these three different points, they are different. In the steady state also they are different, but they are not increasing with time. Whereas these three readings that we took from 0 to 30, from 30 to 60, and from 30 to 90, here the temperature of each point, each cross section of this metallic rod, they kept on increasing with time until we finally arrived at the steady state. This is the steady state, the 5 minutes, that thing. And these three are the variable state. Variable state of thermal conduction. This is the steady state of thermal conduction. Here, after reaching steady state, the temperature of the metal rod, these 3 points, the temperature of this section, it will not increase beyond 200 degrees Celsius. The temperature of this second cross section will not increase beyond 150 degrees Celsius, and the temperature of this third section, it will not increase beyond 100 degrees Celsius, because steady state has reached. Okay, but when we were in the variable state, first we, the initial reading at 30 seconds, it was 50, it increased from 50 to 80, and then from 80 to 110. Here the second section, it increased from 30 to 60, and then from 60 to 90. It kept on increasing. And the third section, it increased from 10 to 40, and then from 40 to 70. And finally steady state was reached at this. Okay, this. And here this is not an actual data. I'm just giving you an example, and these numbers are not they are not real. I'm just giving you an examples. Okay, so don't get confused with that. So this is the concept of the transition from variable state to steady state. So in steady state, there are some important characteristics. The first one is the temperature of two parts of the rod are different. Okay, here also, like we saw, the temperature of these three parts, they are always different, also in variable state and steady state also. But in variable state, the temperature of each part is increasing with time. In steady state, it is remaining constant. Okay, so in steady state, the temperature of the different parts of the rod are different, but each part, the temperature of each part, it remains constant. And each transverse section of the rod, it behaves as an isothermal surface, because all the points on this section, it always remains at a fixed temperature, and the temperature decreases as we move away from the hot end. Okay, that pattern you can see also here. Always the temperature of the section which is closer to the hot end is higher, and that which is far away from the hot end, that is lower. Okay, here 50, 30, 10, 80, 60, 40, 110, 90, 70, and in the steady state 200, 150, 100. The section which is closer to the source of heat, or the fire or whatever it is, that is always higher. And then the quantity of heat flowing per second through every cross section is constant. We know that heat flow depends on the temperature difference. In the steady state, as temperature difference remains constant, it is not increasing with time, it is constant, then the quantity of heat which will be flowing, that will also be constant, isn't it? Heat will keep on flowing, but no absorption of heat will take place. That is the critical difference. Okay, see, in steady state, heat flow will be there. Okay, heat flow will be there, but no further absorption of heat in any part. That will not happen. Okay, so here understand, here in the initial state, the temperature difference between 1 and 2, it was 20 and this was 20. Okay, in this case it was 20 and 20. Like this, the temperature difference was there. In any intermediate case, it can be like this temperature, it will reach to 60 and it will be still at 30. So the temperature difference will be 30, and here it is 30, here let's say it is 20. So like that. So the temperature difference, it will fluctuate in the variable state. But in the steady state, the temperature difference between 3 points or any number of points, let's say you see here I have taken 3 sections, that's why I'm saying 3 points. But any 2 points, okay, any 2 points, if you take any 2 points, the temperature difference, let's say this is TA, this is TB, like this. Any 2 points in the steady state, the temperature difference will be same, because in steady state, these temperatures of all these cross sections, it will be fixed. So as the temperature difference is fixed, so the quantity of heat flowing through them, that will be constant. But in the variable state, the temperature difference is not fixed, because the temperature of each part is increasing with temperature, is increasing with time. The temperature of each portion, it is increasing with time. As a result, the temperature difference between the different cross sections, it will change, it will fluctuate, and as a result of that, the quantity of heat between any 2 portions, it will be different. Okay, that will also fluctuate. But in the steady state, the temperature of each section, it will constant, and the temperature which is of the section which is closer to the source of heat, that will always be higher than the section which is far away from it, as you can see here. Okay, so this is the basic concept related to variable state and steady state. Okay. So now let us discuss about temperature gradient, which is an important concept. So let us take this metal rod which we are discussing and take any two cross sections, two isothermal surfaces, S1 and S2. Let's say S1 is at temperature T1, S2 is at temperature T2. They are separated, let's say, by a distance x. Okay. So temperature gradient is simply the ratio of the temperature difference between any two cross sections, in this case S1 and S2, that is T1 minus T2, and the separation gap or distance between them, that is x. T1 minus T2 by x. It is the rate of change of temperature with distance in the direction of flow of heat. Here we know heat flows from an object at a higher temperature to an object at a lower temperature. T1 is greater than T2, so heat will flow in the direction from S1 to S2. So temperature gradient is also measured in that direction. T1 minus T2 by x, rate of change of temperature with respect to distance in the direction of flow of heat, that is called as temperature gradient. Unit, it is unit of temperature in the SI unit, it is Kelvin per meter. Distance meter, temperature difference in Kelvin. And it can also be measured, expressed in this way, that is delta T by delta X, or in differential form dt by dx. Okay, so this is temperature gradient. So here we have discussed about thermal conduction in two ways, that is the two important phases of thermal conduction, the variable state of thermal conduction and the steady state, and their important characteristic features. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.